Now, when you're looking at a least square line, you need to know how good the line is, how good of a line how well it describes the data. If I had points here, 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 and here, and I said, draw a line that describes that data, well, that one might, or that one might, or that one might. Those are actually all terrible descriptions of the data. I actually don't know how I could describe the data very well when I draw something like this. So we need some way to be able to tell when the line that's describing this data, that's modeling this data, is not very good. And this is exactly what the correlation coefficient tells us. This is a more complicated calculation. I'm not going to go through and do this one manually. I'm just going to describe the range of values that we can get for this correlation coefficient. In general, the value of r always ends up being between -1 and +1. So no matter what's going on, what line you get, how well it describes the data, it's always r is always going to be between -1 and +1. This is a little bit strange. R is actually showing that it's a good fit to the data if it's towards the extremes of that range. So if it's close to -1 or to +1, it's actually, you know, it's kind of weird. If you have a positive slope and it's a good fit, it means it's going to be close to +1. If you have a negative slope and it's a good fit, it means it's going to be close to -1. So because these rules are a little bit, actually I guess I said it right here. If r is close to 1, that means the slope is positive. If r is close to -1, that means the slope is negative. And it also means that it's a good fit for the data. Alternatively, it's commonly, instead of talking about r, because r has this weird thing, it's good when it's way down low or when it's way up high, well, when it's close to -1 or +1, because it has two separate areas where it's good. Alternatively, it's bad if it's close to 0. Sometimes people look at r squared instead of looking at r, and what that does is it kind of folds this over. All those negative values become positive, and r squared always ends up being between 0 and 1. And in this case, what values of r squared imply a good fit of the data, and this would be just if they're close to 1. And what you need for a good fit is highly dependent on, how accurate you need to be. So, in general guideline, if it's 0.8 or higher, then it's usually close enough, good enough to actually use to feel like it models the data, or at least that's my personal opinion. Anything less than 0.8, and it starts to be really questionable whether or not it's actually describing the data. There is no, I would say 0.8 is a fairly decent cutoff for r squared.